Okay, so we are back with lesson 8-7, continued talking about exact values, so multiplying and dividing of square roots with exact value. We're going to do several examples. So if the last video kind of left you clueless, don't worry, we're going to keep on trucking. This is not an easy concept, and it's extremely hard to do in a video, especially when you can't, see my calculator and that kind of stuff, but I'll try to explain it as best as possible. So first of all, you need to know those perfect squares. So as you can see, I wrote all the perfect squares again up here because we're going to use them. And we're going to do several examples. So here we go. I think we left off with example number 6, the square root of 588. Now, off the top of my head, I don't know what numbers go into 588, and that's what I'm looking for. I'm looking for two numbers that I can multiply to get 588, and one of them needs to be a perfect square. And I try to find the biggest one that I can. So I've got my calculator handy right here. I'm going to do 588 divided by, I never use 1 because that doesn't change anything, divided by 4. And 588 divided by 4 does work, but it leaves me with 147, which is a huge number that I really don't know the factors of either. So I'm going to keep on going and see if I can find something bigger. So 588 divided by 9. Not even. So I'm going to keep going. 588 divided by 16. Not even. It's a decimal. I don't try 25. And the reason being is if 25 is going to work, the number that you're trying to divide has to end in 5 or 0. That's the rule of 5. And 8 isn't a 5 or a 0. So I'm going to keep on going. So I'm going to skip over 25 and I'm going to do 588 divided by 36. Not even. So I keep on going. 588 divided by 49. That works. In the other multiplier is 12. And that's a number that I know. So I think I'm going to stop there. There is technically one bigger. So if you wanted to keep going, you could. I just try to do some numbers that I know. So 49. So your ultimate goal is to try to take the square root of something. So now I know the square root of 49. The square root of 49 is 7. So I've taken the square root of it. I'm going to highlight that in yellow because I've actually taken the square root. It no longer has a square root symbol. Now, square root of 12. There's still a perfect square that can go into that. And that would be the square root of 4 and then times the square root of 3 because 4 times 3 is 12. I can take the square root of 4. The square root of 4 is 2. So now that I've taken the square root, I'm going to highlight. And then the square root of 3, there's not a perfect square that I can divide that by. So that is finished, and I leave it under the square root symbol. So that means I have 7 times 2 times the square root of 3 gives me 588. So 7 times 2 is 14, and then times the square root of 3, that's the exact value. So that's what we're working with. We want exact values so that the mathematical world can agree on things. So here we go. Example number 7. Now, I'm going to combine some Pythagorean Theorem and with what we know, because next year you guys are headed to geometry, and geometry uses exact value a lot because, things aren't, equal. So, and they don't round a lot. They want exact value. So therefore, that's why we're teaching it this year. So let's do the Pythagorean Theorem here. So of course, it's a squared plus b squared equals c squared. My two legs here are 2 squared plus x squared, and my hypotenuse is 4 squared. So 2 squared is 4 plus x squared equals 4 squared, which is 16. Now I'm going to go ahead and subtract 4. I've got a two-step equation here, and those cancel. That gives me x squared equals 14. As you know, what we did before we knew about this exact value business, we would undo the squared by taking the square root of both sides, because what you do to one side, you must do to the other. That gives you x, but now I don't want a decimal for the square root of 14. So now I have to figure out, and it's not 14. Way to go, Mrs. Smith. It's 12. Hello. 16 minus 4 is 12, not 14. Sorry about that. New math. All right, so I need the square root of 12. Square root of 12 is not a perfect square, as you can see up there from my list. But I could find a perfect square that goes into that, and I could break that into the square root of 4 times the square root of 3, because 4 times 3 is 12. I can take the square root of 4, which is 2. So now I drop the square root symbol. Oops, sorry. And because I've taken the square root of it, and now it's on the outside, so I'm going to highlight that in yellow. Square root of 3 I can't do anything with, so I'm going to leave it on the inside. So the square root of 12 in exact value would be 2 the square root of 3. So that's what you would say x is. X is 2 the square root of 3. And you will see that in geometry quite often. All right, so let's move on. Number 8. Number 8 is taking it up a notch. It's 8 the square root of 90. So now, do you notice how it's got 8 on the outside? It's just kind of a little more math, but it's already done. I'm going to highlight it in yellow. There's nothing I have to do with it. I just have to include it in the end. So now I'm going to work on the square root of 90. So I can think the square root of 90 off the top of my head because that's a pretty easy number to deal with. I could do the multiples, or not multiples, the factors of 9 and 10, because 9 times 10 is 90. Now, 9 is a perfect square, so the square root of 9 is 3. I'm going to highlight that because I've taken the square root of it. And the square root of 10. Is there anything perfect square-wise that goes into the square root of 10? There is not. So that means that's going to remain under the radical, under the square root sign. So for this one, I have that 8 that I already highlighted times 3 times the square root of 10. 8 times 3 is 24. Square root of 10. So the exact value is 24, the square root of 10. All right, so now let's talk about this in terms of division. So we've only done multiplication at this point, so let's talk about division. Number 9. What if I have the square root of 40 divided by the square root of 10? Okay, well, remember, according to that property that we talked about, you do the division first. You put the division underneath one radical, underneath one square root, and you do that first. So you're going to do 40 divided by 10, and 40 divided by 10 is 4. Now you take the square root. Well, the square root of 4, that's pretty easy. We know that. That's 2. And dun-da-da-da, that's our answer. Okay, so let's do another one. How about something like this? 10. The square root of 6 divided by, 6 to the third power, excuse me, divided by the square root of 6. Okay, so some powers, and of course this is the exponent chapter. So under the radical, under the square root sign, you're going to do 6 to the third power divided by 6. Well, as you know, if there's nothing there, that's kind of that ghostly Gladys 1 I talk about. So therefore, I'm going to do the division first. So that means keep the base the same and subtract the exponents. So 6 minus 1 is 2. Now I want to talk about this one a little bit. 6 squared. I can do this 2 ways. 6 squared is 36. So the square root of 36 is 6. Dun, da, da, da. But now, if you remember back to maybe the Pythagorean Theorem or some of the square roots when we were talking about what happens if you have a squared and a square root. Well, a squared and a square root are inverse operations. So if they are inverse operations, that means they cancel each other out. Like you have an add 4 and a subtract 4. Those are inverse operations. They cancel each other out. So a squared and a square root cancel each other out. And lo and behold, you're left with 6. And that was our answer to begin with. So, all right. That's video number 2. We're not done yet, though. We're going to move on to video number 3. And video number 3 will take into account variables. We haven't talked about them yet. So here we go with the next video with variables. Yay!